I am now. All right, number one. I have a sum of cubes. I know that because I have my little yellow chart here, and I see that the x has a little 3 above it, so I'm pretty sure that 27 is a perfect cube. If I look at my perfect cubes, lo and behold, 27 is a perfect cube. It's 3 cubed. So I'm going to rewrite this. Okay, I'm going to rewrite this as 3 cubed x cubed plus, and I'm going to look up 8 here, see if 8 is a perfect cube. Sure enough, it is. It's 2 cubed. Now I can pick off my little a and b. Because I'm following my flow chart, factor out any common terms. There are no common terms. What type of polynomial do you have? I have a 2-term polynomial, and I know it's a sum of cubes, so I'm going to need my a and b and use this formula. So what's my a and b? Well, it's the base that's being cubed. So I have 3x, and my b is going to be 2. And I just put it in this little formula thing. Don't forget your purple and yellow sheets tomorrow. Okay, so I have a plus b, a plus b times the quantity, a squared. Now, what's a squared? Remember, I'm taking 3x and I'm squaring the whole thing, right? So I need to distribute that 3 to each one of those. So I get 3 squared x squared, which is 9x minus AB. So 3x times 2, 6x, plus b squared. B squared, well, that's 2 squared, which is 4. So there's my answer. Questions? Okay, I have 7x to the fifth minus 112x. Now, we never ever factor. So I'm looking at this and I'm thinking to myself, because I can think to myself, I wonder if 7 is a factor of 112. I'm going to try it. Bless you. I'm going to take 112 and I'm going to divide it by 7. And sure enough, I get a whole number 16. So I can factor out a 7 because that's what my purple flowchart tells me. I'm going to factor out a 7 first. In fact, not only can I factor out a 7, but I can factor out a x. So 7x to the fifth divided by 7x is x to the fourth minus 112x divided by 7x is 16. Okay. Now, this is actually a difference of squares. Okay, this x to the fourth I can think of as x to the fourth. I can think of it as x squared. Okay. And 16 is 4 squared. So my A is going to be the base x squared that's being squared. And my B is going to be the base 4 being squared. Now, again, if I followed my flow chart, this is a difference of squares. Oh, that's a typo. This should be minus on the purple flow chart. Okay, so don't forget your 7x. I have a plus b, so x squared plus 4, and a minus b, x squared minus 4. Now, being in Algebra 2, you should realize that this is another difference of squares, right? What's your a here? What's being squared? X. And b, what's being squared? 2. We know that this has imaginary numbers from our synthetic division that we've been doing. That's 7x times x squared plus 4, and another a plus b, a minus b. So I have x plus 2 and x minus. That, my friends, my final answer for $1 million. They're going to be in extra copies, Algebra 2, and yesterday was Monday. Huh? Yeah. All right, 3A. I didn't understand one word you said, but you know what? That's okay. That's okay. I don't want to. All right, I got to follow my flow chart. I have 4 terms. I can't factor out any common factors. I have 4 terms. That means I have to factor by grouping. Group the first 2 terms and the last 2 terms, greatest common factors, and then check for any further factoring. Okay, get a group. Group the first 2 terms, second 2 terms. Okay, what can I take out of the first 2 terms? Well, I can take out a 4 and a 2 x. 4 x 8x squared divided by 4x squared is with 2. Second quantity, I can factor out a negative 5. Negative 5x divided by negative 5 is a positive x. Negative 10 divided by negative 5 is a positive 2. Now the whole idea here is to get the same quantity, right? So I get my x plus 2. And what I have left over is my other quantity, 4x squared minus 5. And make sure that you can't factor this any further. This is not a difference of squares, so I'm pretty safe saying questions on factoring. All right, long division. Okay, so I'm going to take the polynomial 3v squared, subtract 31v minus 31v plus 67. And since this is long division, we're going to use the divisor as is. V minus 7. Okay, so I'm going to do some side work here. I think to myself, or I ask myself, well, I have this divisor v minus 7. What am I going to multiply that v by to get 3v squared? Well, I need a 3 and I need a v. So I'm going to multiply it by 3v to the first, so I'm going to keep it for the first. And then I have to multiply it by this second term, which gives me negative 21v. So that's my product. 3v squared minus 21v. Now, I'm going to subtract the entire product. So I'm going to put parentheses around there. Okay. 3v squared minus 3v squared. And the whole idea is to get a 0 for that first term. Negative 31v minus a minus, which makes it plus 21v, gives me a minus 10v. Bring down the next term. Okay, do it all over again. What am I going to multiply v minus 7 by to get negative 10v? Well, I need a negative 10. I'm going to multiply it by negative 10. Negative 10 times negative 7 is positive 70. So here's my product. Negative 10v plus 70. I'm going to subtract the entire quantity. Negative 10v minus a minus is plus. 10v is 0. Positive 67 minus 70, negative 3. I have no more v's, so that's my remainder. So my answer is 3v minus 10 minus my remainder, 3 over the divisor, v minus 7. Okay, let's keep going. Number 11. Divide by using synthetic division. Okay. So I need my coefficients of the polynomial. So I have 1 a to the fourth. 1 a to the fourth minus 36 minus 30. Oh, what do I have for k cubed? What's my coefficient for k cubed? 0, right? I have a 0 k cubed here. I almost made the mistake and forgot to put the 0 there. Okay, this coefficient is actually 0. I would have gone through the whole problem and made a mistake there. I need a 0 there. Then I have a minus 36 for my k squared. And a plus 8 for my k, and negative 48 for my constant. Now, for synthetic division, I need my 0 here, not the factor. I need the 0. So I have to take that k minus 6, set it equal to 0, and actually my k equals 6. So that's what I have to divide by, a positive 6. Okay, bring down the 1. 1 times 6 is 6. Don't forget we're adding this time with synthetic division. 0 plus 6, 6. 6 times 6, 36. Negative 36 plus 36, 0. 0 times 6, 0. 8 plus 0, 8. 8 times 6, 48. Negative 48 plus 48, 0. So here's my answer. I'm divided out one of the k's, so I have 1k cubed plus 6k squared, and plus a 0k to the first. Now you can put a 0k to the first in there, or you can simplify and just leave it out. Plus 8. I'll take either one. I'm not real picky. $13. My coefficients of the polynomial, I have a 3x squared minus a 19x to the first minus a 43. The divisor is 8, is x minus 8, so my 0 is going to be positive 8. Okay, bring down the 3. 3 times 8 is 24. Negative 19 plus 24, positive 5. 5 times 8 is a positive 40. Negative 43 plus 40, negative 3. So my answer for this one, 3x, we're going from an x squared, so it's x to the first, plus 5. And I have a remainder of minus 3. Now I got to go back to the divisor for this. I can't put it over the 8. I have to put it over the x minus 8. Um, 4a. I don't know why they're asking this question when they give it to you right here. Okay, how do you determine how many solutions a polynomial has? It says identify how many solutions a polynomial has based on the degree. And then the 4B, I probably won't put these on the quiz because I don't know what the purpose here is. Write an example of a polynomial with 4 solutions. There's 4 solutions. So I'm not gonna. That's just give me points. All right, using your calculators, find all rational zeros. Then use that to reduce with synthetic division. Find all other zeros of the polynomial. Okay. You ready? Are you ready? Are you ready? Are you ready, kids? There you go. See, somebody's paying attention. All right. We need to put this in a calculator to find any zeros from the calculator. All right. X cubed minus x squared plus 25x minus 25. Graph. And I see I have, looks like 1, 0. So this is probably going to be the one real solution with, let's see, I've got 3 solutions, probably 2 imaginary solutions. Okay, I'm just going to double check. It looks like 1, 0. I can double check by using my chart. I'm going to go to 1, and sure enough, that is a 0, 1, 0. So I know from the calculator I have the number 1 as a 0. So I'm going to divide synthetically using the 0, 1 by coefficients 1 x cubed negative 1x squared plus 25 minus 25. I better get a 0 here. Okay. Bring down the 1. 1 times 1, 1. Negative 1 plus 1, 0. 0 times 1, 0. 25 plus 0, 25. 25 times 1, 25. Negative 25 plus 25, 0. So I get, let's see, I'm dropping down to an x squared, 1x squared, plus 0x to the first, plus 25. Okay, so I get this quadratic, x squared plus 25. Now, I got a couple of choices here. I could put this in the, I wish this was a minus because we have a formula for different than perfect squares. This is a plus, so I know I have imaginary solutions here. Now, I've been teaching you to use quadratic formula, right? Put this in quadratic. There is a shortcut way of doing this. You could just set this equal to 0. Huh? Yeah. I could just set this equal to 0 and solve for x. Subtract 25 from each side. I get x squared equals negative 25. Take the square root of both sides because it cancels out the power 2. It's plus or minus. I get x equals plus or minus square root of 25 times the square root of negative 1. And we know that the square root of 25 is 5, and the square root of negative 1 is I. So there's my 2 imaginary solutions. I have one from the calculator, real solution, And then my imaginary solutions, I have plus or minus 5. Now, 5B, they're giving you a trick question. Why don't you guys go ahead and try it? Try it right now. Okay.